So the RTE, you ever hear that? Roman termination event? I've never heard that referenced that way.
Termination.
The Roman termination event.
You might think you're sharing, but you're not.
Oh, I'm not. Okay, thanks.
Yeah. It's so normal for you to think that you're always whatever's on your screen. We're all looking.
That's
at.
right. Yeah, I know.
See?
I'm looking around. You can tell I'm looking.
I know
around.
you.
Yeah, thanks. Yep, you're right.
Oh yeah, I could hear it.
Yeah. Can you see it now?
Oh yes, definitely.
Okay, good. Let's see. Here we go. All right, I got it.
Oh wait,
this is Electric Universe.
Oh yeah, this is.
So is this your face mask?
Yeah, that's what I use so I don't breathe in the deathly chemicals.
Right. All right.
I looked up what was inside of that clay, and I could get cancer apparently from inhaling any of the fumes coming off of that clay as it is burning. So
okay,
I don't want cancer.
No, it's never good.
No, probably not.
I don't want that.
Welcome to the October 30th edition of The Electric View. I'm Neil Thompson. Today we have Jim, Eugene, Heather, Buddy, Robert, David, and David. We'll be discussing planetary electrical experiments by David, the difference between the electric universe and plasma cosmology, and also discuss the nature of the paradigms. Please like and subscribe.
So, explain what you're up to here.
Yeah, sure. So this was an idea I got from Robert last time we talked, and he was asking, man, what if there's a way that you could rotate the ball? I want to see what that discharge looks like. So this was my first attempt. I had a wooden dowel that I stuck in between the two poles. Had a piece of clay wedged in between the two, and was able to just rotate that wooden dowel from a distance. So this is not letting the electricity just sit static. It's actually discharging. And, I see to me, it's like a big crater field or a minefield. You could just kind of see where the arcs are just blasting little pieces out.
Right.
So I didn't do this portion very long. I didn't really need to. So then I'm moving on to this next part, which is just a little wedge piece of clay that had dried overnight. It was probably at least 48 hours. And just dab some water on top. Obviously, when it's completely dry, doesn't do much. But as soon as you get it wet, that discharge starts happening, and then you see it soak into the clay, and it'll do various etching in there. And I noticed that it gets to a certain point to where the right moisture level just makes things explode or vaporize. So it's interesting to see the difference between completely damp clay or completely dry clay. Again, we obviously know that, you got contraction and expansion anytime it dries up or gets wet. But my next task is to add in some metal shavings or some metal dust in here to see if you got a little bit more metal content in there.
Yeah.
How it works differently.
I'm actually really impressed. One of the things that you just basically described or showed is what happens to the shoreline during some of these events, because the shoreline will be the first that's attacked, and we kind of already knew that because of fjords in northern Canada. Kind of the idea, because it would be really right underneath the northern lights that should be struck, and we see like cliff faces that are just straight up and down right there. And of course, the water would keep flowing back in because it's sea level and so forth. But in your situation, you could watch something evaporate. Like if you were at a lake, for example, and the lake happens to be one of the places that hit, you'd think you'd be safe. But it wouldn't take long before the electricity just vaporized the entire shoreline and kept on removing the water. Because it looks for a good hit right along that boundary layer. And we've noticed that before. And it's not wet. It's where it's damp is the most conductive.
Yes. Yeah, and it's got to be a fine balance. If it's completely drenched, doesn't do much. Um, it's a, it, it's
You're
a
creating an electrolytic solution, so to speak.
Mhm.
Like where it's just conducive to electric charge flow through. Because if it's too wet, you have a boundary layer, and if it's too dry, you have a boundary layer, and the place in between, that's what you like. It's mucky and lots of ability for currents to travel from point to point to point.
Yeah.
And blowing chunks of the land like that. That's creepy.
DJ, I thought of you on this next part, or actually, this was maybe a month ago. You guys were talking about the feng shui and the dragons going through. And this part right here on the right, where you see the electricity kind of come through this material, reminded me of that. Like they were putting the holes in the buildings.
Oh yes,
to allow the pathway of the energy to flow, or the spirit to flow. It just made me think of that when I saw that.
Right.
We've actually seen quite a bit of evidence of that.
Yeah.
If you go to West Forks in Sedona, that's not too far away from the Grand Canyon area. You can see these. Now they think it's made by water, but it's clearly not. It's very rough, and you can see that what it looks like. You can see the evidence of a path of electricity going around a corner. Ions flowing and then spreading out, and you could see the dropping of certain materials like iron would drop out of it, and then it just fanned right out. You could see that it struck the far end of the cavern and everything, and you get to see similar things to what I'm seeing here, except obviously in scale.
Hello.
Hey.
Look who's chosen to arrive.
Oh,
yeah.
Late as usual.
Oh man, great.
I usually have rehearsals with my band at this time, but today something went wrong, so I don't have. Yeah.
Okay. Oh, thanks for joining us, Eugene. Yeah, nice.
What do you play?
Yeah. I play bass guitar and I sing.
Right on. You're the most important part of the band.
That's right.
Keep the rest.
Yeah, probably. Although I would like somebody else to sing because it's I have a pretty low voice and it's punk rock where you need a very high voice, kind of.
Right on. I'll come sing with you.
There we go. Get the band going, man.
Now we're talking.
Yes, sir. These were a couple of shots I snapped prior to finishing it out. About halfway, I took shots of this and then continued recording. So it's.
Wow.
I noticed there was kind of this cool ridge line. One side of it had this kind of pitting, and then the other side seemed like it was just straight cliffs. Kind of interesting ridge line here.
And now you're filming it.
Well,
hold on one second. The filming. Sorry, the filming that you're doing, because you're getting really, really nice shots. What's the setup that you're using, if you don't mind my asking?
Oh, sure. This is I forgot the brand, but I just ordered a digital microscope, and so it hooks up to my phone, and I connect over Wi-Fi to this little box it came with.
Cool.
And I can go 40 zoom or 1,000 times zoom.
Wow, nice. Yeah, you're getting really great shots here.
Yeah, man, just being able to see it close up, you really see the texture and what the effects are.
Right.
Before with zooming in with my phone just didn't do it justice. So it was a very cheap investment for me to get something more detailed here.
If we were looking at this with a light from only one source, I would be hard pressed to separate this from places where me and Robert went walking through the San Rafael swell. Some of those things were, I mean, I swear to God, if you look at some of the videos that I've posted, my geology tour for 2017 with Robert in it, you can see some of the rock faces. If you just put a direct angle light across it, you would be, if you could imitate the sun, basically, you wouldn't be able to tell the difference between that and what we went through.
Interesting. I could take some more shots in the dark with some light.
Well, I wasn't trying to insist. I was simply showing you could probably play that game where take a still frame and then another still frame of a landscape. And like, is this Earth, or is this a clay ball, or is this Mars? Is this,
Yeah. No, I mean, it's such a strong argument, just as far as, just the beginning of talking about how potentially how exactly all the geology was formed by plasma events. Just really, really strong.
Mm-hmm.
Especially looking down. I mean, this looks like the top of a Tepuy in Venezuela. They're flat top table mountains, and they have melted figures all over the top of them and pitting like boreholes. And that's what it looks like, just what you were showing there. It also looks like parts of Mars. I usually compare those two, but now I have a third comparison. They all look very similar.
I've got another video I just uploaded last night, late last night, and it was same setup here, except I used a cube. I made a cube out of the same clay.
Oh man, now we're gonna get esoteric.
Yeah, but it's fresh clay, so it's completely moist clay just as you get out of the box, ready to model.
Okay.
And it had a dramatic different outcome.
Okay.
There in the end, though, it did look like
this
the surface
is
of Mars to me.
Size. Today, I'm gonna try something.
Let's see if I can get there.
There you go, the clay filaments. Yeah.
This one.
Okay. Yes, sir.
This is electric universe size, and today.
Okay, cool. Get your window out of the way here.
Yeah, so I do an overhead recording of it, and then it'll go into the digital microscope.
Okay.
So I purposely put it against one electrode so it just discharge between the gap in the bottom. So I noticed at first it would kind of be an even blue glow, and then it started kind of flaring up. The water moisture collecting on the outside, you could see it in the reflection on the outside of that. Every time I use fresh clay, it seems to sweat on the outside, and then the material starts to move back and forth, and you'll notice these filaments start collecting here, and it gets pretty dramatic, and then they start to kind of pop out and bubble, and then you'll see focus points to where it seems like it's latching onto something, or I don't know. I want to describe it as a Z-pinch, but you'll see here in a moment
where it kind of pauses, and it's like it all goes through one point, right? And then
and maybe that area is just heating up and it explodes outward.
Yeah. Mm-hmm.
I like how the little filaments start to dance around.
Yeah,
that's my favorite. After a while,
really
once
cool.
it dries out enough, it actually starts pushing those filaments backwards. So it's creating kind of an electric wind, which I've seen before in other people's experiments, where instead of an attractive force, it's repelling.
I'm seeing vortexes in there.
Oh, yeah.
Well, each one of those is a pair dancing around itself, kind of.
This is what I imagine the Dogon tribe dancers mimicking, seeing this type of discharge in the sky.
I think most dance coming from this.
There you go.
I honestly, when I spoke to Gata Che after EU 2017, brought up this very subject, because it's mentioned in a lot of things, like you got the dance of Shiva, it was mentioned in kind of referenced in Avatar, the cartoon, the series, where they had the dancing dragons, all this stuff that was originating.
Yeah, the
rooted in the
dervishes.
original stories. Like, yeah, Terpsichore, the Greek music, dance. So they all come from like this chaotic event in their past where they do the dances to pay homage. And I think that's where all this originated.
Yeah, but I mean, there's the consciousness, the enlightenment, whatever would we call it? It's a meditative experience of transcendence. That's what they're going for with it.
This part here too, seeing these filaments kind of grow out and be attracted, kind of reminds me if we took this and rotated it to the left, to where the clay would be the earth, and we've got the electricity coming from the sky. It gave me the visual of plants growing. Watching plants or trees grow. If you've ever watched that in sped up
coming
time.
off the material on the
on
left.
the clay ball.
Yeah.
I was looking at this. It looked like the top of my head, and I was thinking maybe I could grow hair.
Hey, we got to. Hey, there we go.
I have that same little mark. I just hit. I got a crease just like that. Well, if I could get one of those plates and.
The thing is that this material building up is only doing this because it's so incredibly light. If it was, say, actual rock and we're dealing with landscapes, then these would be forming mountains.
Yeah, it'd be hardening. It would be turning that wet clay into a rock, whatever actually maintained. Right?
Oh yes, it would be falling down over the area. Being itself. Wow! Look at the chunk it's taking out of the corner there.
Such great shots here.
Watch this bottom left hand side. Watch this. It's gonna just start like fingers just start etching in these little holes.
Those are the vertical things that Andy was talking about, running across the landscape and creating supersonic shock waves, because that's what they're doing. They're reaching. They're looking for more current across the surface.
And each one will be like one of those streamers that Jacob Gable showed. He's eating into the ground, right?
Yeah.
You're hooking this up. This is this is AC or?
Yep.
Yeah. Okay.
It would really be. I mean, obviously, most of it would be DC in real life, but there's a distinct AC vibration going on there, because that's what really passes through the capacitive layer anyway. We have a really good shell, a really good protective layer, about a mile or two of good thick atmosphere, which the lightning that we're looking at would be above that, in most cases. But there would be instances where it would run across the ground, and in those it would be just, devastating.
So
it's like 60 hertz.
Oh wow!
Yeah, this would be the debris field. I just stuck the microscope on there, and then that was what was left over. So it.
Wow! Look at that.
If Robert, are you on? His picture's on. He's not there.
Yeah, I'm on.
Okay, that I have looked. We have this microscope very similar to what this is, and I've been looking at the rocks that we have for 20 years, and I used to say, hey, this looks like meat when you would look at it under that. We had it on a 100-power microscope at Brigham Young, and it looks exactly like those things. I could go up and put this on and just show you rocks that have craters that are chain craters. Everything that you can see, we can zoom in on the same way. It's amazing how much this rock with the fused surface on top, everything about it is electrical, just like that.
Mm-hmm.
So
until you get to a certain level, then it starts to turn into those little beads that are fused together, and then it has those weird filaments.
Yeah, the filaments.
Yeah, those are
just
I'm on my phone right now. I pull up a picture. I can't right now, but I think they're on the electric geology site. Facebook, they're in the photos section somewhere early on. If anybody wants to look at it, you can even see some of the filaments in there.
Huh.
And it's also in the obsession stone story itself, where the filaments are blown up. You can see that one. Neil saw them the other day when we had him in the show that one time when we got back to Denver. Do you remember, Neil?
Oh yeah.
Yeah. That was kind of blowing your mind.
All of this is blowing my mind every time I see it.
Wow.
If anybody wants to cite and then share it real quick, Electric University, it's in the files section. Just pull up the obsession stone story. You'll see what we're talking about. Wow.
So Neil, you had mentioned, you were talking about the AC current in our atmosphere. How do you think this would react differently if it was DC? I mean, in comparison to an Earth situation.
Well, okay, it's actually break down to the brass tacks of it. There's a capacitive layer, an ionosphere is a general capacitive layer that is separated by an electric field. That electric field and the dielectric within inside of it generally is considered a complete open circuit to a DC current, because what allows a capacitor will allow AC through because the plates will charge up at different speeds, right? Mm-hmm. And that's how you can create dampers and buffers and all this other stuff. But with that, I would think that to get a direct current through, you have to really do that twist motion, and this is why we have this the hurricanes and tornadoes and so forth. They are what gets through the bottom layer, the really thick stuff. They can't get any closer to the ground. Now, when it comes to AC passes through capacitive layers like they're not there. So any vibrations that were being made, that's where the piezoelectric vibrations and stuff like that inside the Earth, the whole Earth moaned when some of these events were occurring, according to description. So you can envision how much alternating current there was. And so clearly, but that usually a lower amount than the direct current. But obviously, the direct current will create little twists like you're seeing there that will reach deep inside, trying to get through that last little bit of space that it can't get through. Because no matter how much you want to do, you're just going to be squeezing that capacitive layer down. Yeah. It doesn't go away. It's just a property of the Earth.
Okay.
Well, technically, there is a DC through the atmosphere even now.
Oh yes, there's a resistance.
Pretty weak.
Well, given the whole amount of the Earth, it's not totally weak, but per square meter, it's pretty weak. Yeah.
So I've been thinking about a few next experiments. So if I switch this, put a rectifier bridge in there and make this to where it's DC. I've been doing a lot of etching, obviously, electric district machining, but I want to be able to try to build up, on top of a layer instead of removal. So do you think I could accomplish that only with DC?
Well, you'd have to ask Gabe, because he actually uses DC. He converts it over to DC in his experiments.
If you want to create a tornado, for lack of a better term, you're going to need DC. And the reason is because if you keep moving the magnetic field or the electric field back and forth, the electric potential from point to point, you're not going to have the ability for the right-hand rule to take over and to get any sort of spinning action. Plus, you're going to have a definite. You'll want to note. I mean, once you get an AC/DC thing, this is where things like Billy Elverton's experience, though I love him, showed certain things, but a lot of those things might only occur because of the waveforms he was using. Jacob Gable and Garrett Hill have been doing DC experiments, which I think are more because there's a potential, reflective of what's going on. Because there's a potential between this point and this point. It's going to rip material off of that point and put it onto that point. Yeah. It's going to change the material. Some of it's going to fall back down, because this is the way that material goes. There's going to be potentials that are going to create loops, and you're going to have induced loops and other things like that. Now, if you want to be accurate to what some of this was probably like, you need a high DC offset, and then you have to add an AC waveform on top of that, but a small one. And then you put those two together, and that's probably more to what was happening in real life between the two planetoids. But you're getting picky then.
I mean, you're already getting such great. Just one second. You're already getting such great results that it's beckoning to try to model just in scale what the dynamics are that we can actually measure, and then do the scalar translation to your environment there, and then I think it already has legs, but it's like you have big elephant legs if you start doing.
By the way, this is really important when the material, like for example, when you're watching material get blasted off of that clay material, notice it's instantly gone and it doesn't go anywhere. You don't see chunks flying. It's instantly gone and turned to dust. It's pulverized into dust. Mm-hmm. That's a very important thing. Oh, I love the way that the ridge line is being pushed back. There's another beautiful thing. But so if you can imagine that material is being laid down in a strike and then suddenly repulverized and pushed back across the landscape, or a piece of material is lifted from the ground momentarily and immediately turns to dust and just flies into space. If you were to, we have no concept of what that would look like, like to imagine that from a person's point of view on the ground or something. This is electricity doesn't behave as we think that it will,
Well, and to that point, isn't the elevation of Mars, if you look at the elevation levels of Mars, the whole top has been basically lowered in level, and it's been all of the boulder fields and whatnot is on the southern hemisphere, right? If I'm correct.
You are.
So it would seem that it's being etched on the top and then dumped on the bottom hemisphere. So,
yeah, but it kind of looks. The northern hemisphere kind of looks very, very kind of, I don't know, flat or very soft, I guess. But actually, if you look at the photos, they've had some landers that went there in the northern hemisphere, and you would see that it's actually covered with small boulders. There aren't no big rocky formations visible from a larger distance, but it has a lot of small rocks just lying everywhere. So maybe this is kind of the equivalent of this dust that Neil talked about, that was kind of just lifted up. Maybe some of it landed in the southern hemisphere, and maybe some of it just remained lying there. The smaller pieces, for example.
Yeah, there definitely was a lot of etching on the north. Apparently, if you zoom into it, it just looks like little tiny, like the bottom of craters. Just a little. They're all together in little hexagon forms all across the surface. Apparently, with like Eugene said, a boulder field all over the place. And but to understand exactly what happened there, the only thing that's one of the Saturnian things that used as evidence, because it would imply that Mars was etched by something very powerful on the north side of it for an extended period of time, because it doesn't have a magnetic field, right? So if it doesn't have a magnetic field, it wouldn't do what the Earth does and channel it right down to the pole. There'd be something else happening there that caused that top part of Mars to be 3 kilometers less than the bottom part. I leave it to you, but it is definitely very odd.
I think maybe it was Mother Mary.
Yeah. That's an interesting proposition.
Do you mean Venus?
Yeah, Venus or Eve.
Yeah. Or Lilith.
I've got a lot of names for that planet, but
that's the general conjunction would be Mars, Venus, and then Saturn beyond that to the north of us. But that's that model, and I really like it, but I also have to acknowledge that there's there's more than just one part to this. It's deeper than this one story. I mean, there's more to decipher.
Mm-hmm.
Well, I can certainly add one point in favor of this discharge hypothesis, so to speak. Well, remember that, positive and negative were initially invented as plus and minus because of the part which was positively charged was gathering material, whereas the negatively charged part, there was a removal of the material, right? When you have these discharge experiments. Mm-hmm. I believe this is actually the reason for these signs. Okay. So, I mean, if you just take this...
Still there? Did we lose him?
Supposedly, the southern hemisphere of Mars should have been charged positively, right? Because there was an accumulation of material in the southern hemisphere, right? And so, if it was charged positively, then probably the oxygen or whatever else, I mean, negative ions such as oxygen ions, they would be attracted to this southern part, right? Mm-hmm. So there would be a lot of oxidation events in the south, sort of a planetary-wide rusting, so to speak, right? And if you look at the map of the concentration of hematite, this mineral hematite, which is basically rusty iron, right? It's exactly concentrated in these higher elevation southern hemisphere areas of Mars. And it is frequently noted that hematite might be created from other types of iron compounds, such as magnetite, if I'm not wrong. And in these lower areas in the northern hemisphere, there are much more of this magnetite than we see in the southern hemisphere, where we basically see mostly hematite. So in this sense, I mean, in this hypothesis, it is kind of expected to see something like that, where you have a highly oxidated, rusty southern hemisphere where magnetite turned into hematite because of this, large-scale discharge. Whereas in the northern hemisphere, you see more pristine, this, so to speak, primordial magnetite.
That's exactly true with Michigan. Michigan is riddled in hematite and magnetite. There's layers of it, strictly different layers that switches between hematite and a different type of stone.
What are you showing there? I'm seeing a video come through there.
Oh, so welcome everybody. Hi, I'm happy to be joining here, and I have the day off, and I have my setup. So if you guys want to see a live demonstration of these rocks I have set up with the same way I believe you're doing it, David, with what is it, a neon sign transformer?
Yes, sir.
So I got the neon sign transformer hooked up here, and this is a Michigan sandstone rock that I just peeled off the layer. The outside layer was this. And so it rests inside of this as like a concretion. And then there's an inner layer, and this is the inner layer of like a sandy stone. So I'm about ready to plug it in. So it's dry right now, completely dry. Is it coming in all right?
Yeah.
Yeah.
All right.
Be careful.
Okay, just plug it in.
It would be awful to have a live electrocution.
Well, okay, so you can hear it. You hear it?
No.
It's lightly sizzling.
Okay.
Now I'm going to add a tiny bit of solution to it. And if it's very little bit of solution, it should create an arc across it. Or we'll see what type of pattern we can get going here. But it has to be just barely
barely enough to skip together.
Yep, to get it started. And once it gets started, you should be able to see a tracer if I get the right amount of liquid on it. It all has to do with the amount of water. And if you put too much, it doesn't do anything. See?
Yeah.
It stops. So let me see if I can get a little on this side. Yep, too much liquid on this one. But it has to be just exactly right. So I'm going to turn this off. And change to a different stone. Put a new one here. This one I just peeled too. And it's important because right when you peel them is there's like a dusty fine layer in between them. And that acts as a catalyst to create the Lichtenberg pattern that I'm looking for here. Okay, so I just turn the light back on, or turn the machine back on. Let's see what we can get. Okay, we're getting some action over here. For the leader to move all the way across.
Yeah, this type of thing where it's where you're kind of under pressure with a group, I get a little bit of antsy about, because of the experimentation and the potential danger. The danger is bothersome to me.
Yeah, well, I did 2 stones, and neither one of them worked because of I put too much water on it.
Yeah, but you're under pressure, and this is where this, you do it under a bit of a controlled situation, and then you get really good results. And if we were preparing for a show, we would do this. We would do it all beforehand, etc. That kind of thing.
Right.
So anyway.
So yeah, there goes those 2. And yeah, too much water. So it really depends, like David was saying, on the amount of water that you add to it.
It's got to be the perfect amount, it seems like.
Right.
Which reminds me of thunderstorms and lightning and rain. The perfect amount of water, the perfect amount of electricity.
Yeah.
So something comes through.
So, buddy, whenever you get those discharges to happen, is the result very similar to what it is on wood, or does it look different?
It's very similar to how it is on wood, and I'm thinking about getting that microscope that you have there, because I want to see it up close and see exactly what the valleys are composed of. Because what happens is when you can get it to work, it forms a river of molten rock. Mm-hmm. And this molten rock is like lava, and you can see it. It's bright red, and it's a river. And what's left over is a dark type of substance. I'm not sure what type of chemical of composition of the rock that it turns into. So I'm curious to get that tested too.
Yeah. Here,
cool. The one that's kind of like calling to me is like the high speed camera too. Being able to
high speed, nice.
Yeah.
They go nuts with those these days. Where you can get like 400,000 frames a second and stuff.
Yeah,
it's insane.
Well, this I'll find you a link for the camera I'm using. It was like $40.
Wow, perfect.
Yeah, so I'm sure there's something more amazing that I can get later on, but baby steps.
Yes, absolutely. I mean, it's really bizarre. I did the presentation last week, pointing in this direction, and then today you're like right there. It's really remarkable, actually.
Right on.
It's awesome.
So I just want to add one more detail about this hypothesis. So you're looking right now at the elevation map on top and versus the hematite content on the bottom. So as you can see, most of the hematite is in the southern hemisphere, and it more or less corresponds to the higher elevations, right? So maybe it is where this material was accumulated during the discharge that the oxidation of magnetite happened and it turned into hematite. Of course, there's an exception of this, mountainous region, the Tausis Montes, to the southeast of the Olympus Mons, but that's a kind of a separate issue, I guess. So what I wanted to add here is that, hematite, which we see more in the south, it can form again from the oxidation of magnetite. And supposedly it formed on Mars in the presence of water. So the water, kind of rusted down magnetite into hematite. But then if you look at this map, it kind of begs the question, well, why it is that the hematite is more abundant in the south, whereas, the lower areas are in the northern hemisphere, right? So if there were oceans on Mars, they should have been in the north. So you should have had hematite in the north, not in the south. So it kind of, just shatters into pieces this theory, I think, that hematite was created because of water, first of all. And secondly, you don't even have any idea how it came to be that, such a distribution. Except if you think electrically,
Yeah. Could you explain this again? Where the boundary between? Are we looking at two?
Yeah.
Yeah.
Well, this is the lower map. Yeah, this is the same. This is maps of Mars, the
Right.
whole planet, kind of overlaid on a rectangle, basically. And in the top, it's an altitude map. So
Okay.
red means high and blue means low.
Okay.
So you can see here those hemispheric differences, where the northern hemisphere is very low, it's very kind of soft, whereas the southern hemisphere there's a lot of mountains, plateaus, and it's very high overall. And in the bottom picture, it's the hematite content, but the map is the same, essentially.
Got it.
I kind of fit it so it would look almost the same.
Yeah, no, it's very cool.
Yeah, and so you can see that again, the warmer colors are more hematite, and I guess purple is very low. Actually, it's a kind of red is high and violet sort of is low. So you can see that most of the hematite is concentrated in the southern hemisphere of Mars.
Mm-hmm.
So my idea was that probably the southern hemisphere of Mars, again, this is sort of a hypothesis, kind of overstretched maybe, but it's an idea that I had, that southern hemisphere of Mars was charged positively, and thus those oxygen atoms, oxygen ions rather, that was created during the discharge was falling mostly to the southern hemisphere, because they love positive, positive polarity, I guess. And so there was lots of oxidation happening there in the southern hemisphere. And thus the magnetite that was present there oxidated into hematite, which we see right now.
Mm-hmm.
And at the same time, a lot of material was removed from the northern hemisphere. So that's why we see those hemispherical differences in height. So, and it kind of basically explains what we see, at least, But again, if you say,
always
like,
go ahead.
The mainstream guys say that hematite might be created because there was water and it kind of rusted magnetite into hematite. But again, water would be present in the northern hemisphere where it's shallower, where the elevations are lower. So why this hematite is in the southern hemisphere? It's kind of unexplainable, I guess.
Mm-hmm. As always, the experimentalist, do you see a way that you could because of our great respect for you, Eugene. If you were to model with materials just in a somewhat simplistic way, could you set up an experiment that might verify what you're talking about?
I actually think it is possible. Yeah. And actually, I haven't even thought about it, but yeah, I think you're right. I mean, basically, you need a ball, like a ball of magnetite, I guess, and you just have to put it in between electrodes, where positive electrode would be the southern pole and negative electrode would be the northern pole. Mm-hmm. Well, at least, I mean, we don't know what kind of event it actually was, that Mars has been through.
Yeah, no, it would be interesting to play. But at least you can
try.
It would be a combination, like the kind of scientific exploration as well as an art exploration, because it's like, how do you get that? How do you get it to be, look the same, so that kind of thing.
Yeah, it's very cool. I wish I could do experiments like that.
Well, I think that's something that's like in our future somehow. Somehow that's happening. I believe.
I think that's in our wheelhouse. Hey, so we're hematite and magnetite. It's iron oxide, is it not?
Yeah, but in hematite, the it's kind of more oxidated, so to speak. So you can add more oxygen to magnetite and get hematite, so to speak.
So I've got a bag of iron oxide synthetic dust that I ordered. If I mix this into a clay ball and then wire up a rectifier to create DC and have the positive pole on the south pole of the ball, and I could somehow figure out how to rotate this ball in between that discharge, do you think having that material in with the clay would allow for that? That's kind of my first idea of how could I try to do this on a small scale in the lab.
I would actually suggest, doing it kind of horizontally, in the sense that the poles would be arranged. The axis of rotation would be horizontal, because, well, obviously Mars didn't have any, gravitational field. I mean, the external field like you would have with your ball, the field of Earth. So maybe it would be more reasonable to kind of arrange it in a more symmetrical manner, so to speak. I mean, if you have an arrangement where you expect stuff to accumulate at the southern pole, and at the same time the southern pole is directed downwards in your setup, I mean, it's something to be expected that, the pieces of dust would fall down. So,
true.
Sort of. So it's a thing that should be, I don't know. Well, one should think a little bit here. Yeah.
Well, I could try a few things. I think that's a start for some of my next ideas anyway. I was about to add in that iron oxide to see what kind of results I got. I even made a little clay pyramid that I let dry, and I was thinking of just putting the iron oxide on the top cap of that pyramid, just for fun.
Very cool.
So I have some speculate. I have some speculate hematite from Michigan, and it comes off in flakes. I don't know if there's something that I might be able to do with that. It naturally flakes like glitter. But yeah, it's magnetite.
One of the things that's kind of a low hanging fruit, since this is all coming together, kind of naturally and organically, is like we could set up a blog. I'm pretty familiar with doing that, where we all have access to it and just like kind of build the thing and contribute the available things we have to contribute to it. If you'd like.
I like it.
I'm pretty sure Edwin already has a site. Like, I mean, didn't James build a site that we can all just ask and?
Oh, well, I mean, this is kind of specific to an experiment.
Well, yeah, but he's it's all about electric geology over there. Anyway, just an idea, I'm sure.
I had a guess before I go. That scene right before this one where they are showing the pitting and the pock marks on the clay. Compare that to the wave.
You're breaking up, Robert.
Last week or so.
We're losing you. You're breaking up.
But,
hey, Robert, you're breaking up.
You, like from space, and then you can see almost the same pitting.
There, now you're back.
Can you,
You're breaking up on the input here.
Oh, those hawthorns.
Those hawthorns. Damn.
Can you hear me now?
Always a wild card. Yeah.
So what's the fundamental differences between electric universe and plasma universe?
Wow, that's a good one. This video. I'm really enjoying this actually, but in a bizarre way because of my input the perverse, of course. So, hey Neil, what do you think? What do you think of the Bob Johnson video that's bubbling around?
Okay,
here?
I've never seen it, but I've seen the argument a million times.
Okay,
and it's really just a matter of intellectual property. But there is something to be said. For example, the IEEE does not support the electric universe. The IEEE does support plasma cosmology because the IEEE goes, well, it's plasma, and plasma behaves as such. Therefore, we support plasma cosmology. Duh. Kind of matter-of-factly, if you know what I mean. So that's how they generally roll. If plasma makes up the universe, this is going to be the way it is. Now, all of that and everything has to do with cosmology, but not mythology and not changing geology or anything. They're only looking at it from the cosmological aspect, in which the evidence is much stronger for, and on the whole. I mean, that's where the big things, that's where Don Scott works, that's where Ed Dowd works, that's where, this is the big thing, finding that stuff.
Yeah. The
stuff that, if you take that to be a given, just as a given, what does that say about history, mythology, geology, all of the other things? Now, that's the electric universe.
Yeah, it's pretty scathing to Sapphire, though, right? I mean, the 400 volt difference, and then the modeling of it. I mean, that's what I got out of this as far as what's the electric model that's the EU is presenting.
I actually never watched his argument, but I don't want to say that he's a bit. I'm sure that he has some points to make, and I'm going to go review it. But I have that whole sense of someone being very bitter that he wasn't invited to the big boys' table, maybe. But I don't want to say that. I don't know.
I don't know.
Why wouldn't you? No, just be honest.
I will be
Anyone
honest.
Can
well,
go
let's be
EU.
dishonest. Let's be dishonest. I just, if you want.
Everyone can go to the EU conference, okay?
Okay.
And if you're remotely making sense, you can actually be on stage. I mean, generally speaking, Eugene was on stage and he was the scholar. He just like he walked in, hey, here's my paper. Boom, you're smart, on stage. And there goes Eugene.
But Bob Johnson was also on stage at EU 2012, I guess.
Right, but he's obviously has I don't know if his gripe is the nuance. I don't know if his gripe is...
it's a very interesting dynamic going on because it's there's one of the recent things that Wall put out is he's trashing any kind of modeling done on a computer, basically, and then he re-embraces Peratt, where they've been at each other's throats forever, and then at the very end, he's using models to like verify his points. So I'm finding like there's a lot of cognitive dissonance there.
Well, and he's actually making a valid point because, in the sense that, and I don't want to say anything bad about Mr. Johnson because I don't know enough about him to make bad points. It's just the feeling I immediately got. But I don't want to. I want to review it anyway. But
it's always good to see detractors. Of course, because then you either shore up your arguments or you readdress the situation.
Right on the screen, right there is the nutshell. Okay, Tony Peratt is talking about plasma physics in astrophysics and charge exchange between celestial bodies, which is much more local.
This is the premise. Yeah, he's going in. This is just the beginning of the thing. Where he gets into it is,
because
he starts getting into it with what like Alphen had said, and then at Berkeley, et cetera, and then how a lot of things that is being presented apparently as kind of new conclusions were already concluded. And it's scathing for sure.
When I looked at the difference between plasma universe versus electric universes, it seemed like plasma universe really conformed to the current way of thinking, the accepted sciences, but introducing plasma physics and cosmology into it. The electric universe is very, what is the correct word? I mean, it addresses more of the mythological and the questions that everybody has, all of the unanswered and unknowns. To me, it seems like
I'm not a total supportive at all. I'm not advocating any position. I'm just saying that this is something that we should be aware of, and then how do you shore up the argument? Because it's the plasma model, and they call it the GU, which is the mainstream gravitational model, and then disputing currents between celestial objects. That's basically the angle he's taking, it seems.
Well, it's a very fine line he doesn't want to cross.
Right.
And because to be associated with the EU is a death sentence, and they're trying to say no plasma. We're thinking just plasma here. Come on, guys. We're not with them. We're over here. But I think that it just becomes natural.
Well, can't you see we're the box outside of the box?
Yeah, I'm reading it right now. Yeah,
I prefer being outside of the box. I prefer being outside of all. Yeah, here's another cube.
I would actually say that many problems arise when people speak about like in this particular case. I don't think we can even define the terms that we're working with. I haven't watched the video, although again, as I've written Dave a few I don't know, half an hour ago, I really like Bob Johnson's approach to things. I mean, I've watched a couple of his videos from previous conferences, and I certainly would watch this one. But what I wanted to say beforehand is that in this particular case, I don't think we can even define what we're talking about. People say, I mean it. People often say like electric universe theory, but in my opinion, there is no theory. Rather I would call it like a paradigm or a movement of people who basically emphasize the role of electricity, electromagnetism, basically in all the processes, including cosmology, including biology, including meteorology and geology, and so on and so forth.
Right.
And even in these particular fields, there are many contradicting theories inside of electric universe movement. You know, so
also in many of those fields, there's contradictions in the conventional as well.
Yeah, of course. But
the problem is you're going against the dogmatic system and then becoming dogmatic. That's what I see as the hypocrisy.
I would actually think that this was the main kind of pathos of Bob in this. But again, I haven't watched it, so I cannot say for sure.
Yeah. No, Jim brought it onto the radar, and I was like, "Oh man, this is too good not to explore."
It's worth discussing. I
watched it and read his paper, which is identical. I think he was reading it from his paper. If you watch the video or read the paper, whichever. But a lot of his criticisms are correct. It doesn't mean that doesn't mean his theories are right, but still he's trashing some of the clearly wrong ideas that are put out in the EU. See, his criticism, I think, is that the EU went too quickly into what they think is the accepted model of an electric sun, and all he's saying is it's not right, and that is, he is correct in that the EU, these diagrams they show of the electric sun isn't the way current flows. It's not right at all, and he just makes a good argument for that. It doesn't mean that his own ideas on how that works are right, but that was a mistake in EU, is they had these different electric sun models, and in the EU community, it is run by someone who has their own ideas of what's right. He happens to be wrong, but everything else gets shut down. His complaints were the same as mine, in that you should be able to keep open all these different ideas, but he just goes farther in showing what's wrong with effectively the mainstream EU ideas.
That's so weird when you say it that way. But
yeah, well, they're more, in my opinion, the EU has become more dogmatic, more rapidly than the mainstream, as far as, like, if you go up against certain people, you're paddling your own canoe, and they don't want to hear it.
And you're deemed a heretic. You're deemed a heretic.
But I'm just trying to say that these people don't have the power that the conventional people have over your life.
Well, it's microcosm versus macrocosm.
Sure, but the point is that no matter what Wall says, no matter what Dave says, God bless his soul, bless them all. Really, I have nothing against them, but I haven't also had to challenge them the way that you've been challenging some of them, and I think that your points of view have merit in ways that I don't understand. And I have to recognize my own limitations in trying to understand what I'm looking at. But at the end of the day, no matter what anyone says, no matter what, if you're EU or plasma cosmology or anywhere in between, the end result is that you would generally agree that Maxwell's equations and the rules therefore following off of that should have a higher importance in cosmology and generally the way the world works. I think that in that sense, that to me is the electric universe. These people might think of themselves as priests of something, but they're not. You, Jim, can write, and Eugene could get together and write the definitive and become the Bible, so to speak, of the EU. It's not the other people. I mean,
who wants to be that to begin with?
They can't. No, I'm just saying you could, but there's no reason to let these people, like Bob's complaints are perfectly valid if he's not, being just like petty and mean, but he doesn't seem to be. There is some interesting issues in between here. Like, I'm not sure if we're all in the same, the same ballpark here, just looking at the two. But there are some issues over onto the the idea of the sun being necessarily an anode, as opposed to a focus point of but of energy, so to speak, of the currents flowing through. How does this really work? Is it a Faraday disk? Et cetera, et cetera, et cetera. We have to determine a lot of this stuff, but I'm with all the stuff in the plasma side, totally with that too. But I can see most of it's Peratt stuff. I mean, petroglyphs, historical records of plasma events. That's Peratt, in a nutshell. Yeah.
It's interesting because it's everything's in play. It seems like it makes it very interesting for sure. Just from a dynamic, this is kind of we're observing a real kind of somewhat insular scientific, dynamic going on. That's pretty fascinating.
Yeah, I don't know. I don't like seeing people fight over something that is almost pointless to fight over at the moment.
Why is it pointless?
To go to the toe on it?
Why not? I mean, you have a difference of opinion, right? And this is kind of how you shake out, what's the most widely experimentally observed. This is why empiricism is justifiable. Can a collective do this type of observation of a scientific theory and experiment with it and be in some level of agreement on what's going on?
Yeah, see, I think the most important thing is just to not come out. What if I could sum up his criticism? He would almost be saying that that the EU is just saying this is how it works, when they should still be asking how does it work. And the problem is, if you're going to the mainstream and if you have one idea that you're selling, this is the way the sun is charged, this is the way current flows, and it turns out to be wrong, you're doing more damage than good, because that if the mainstream can prove that specific electric sun model isn't right, but you're saying
the whole
that's
thing.
Right. This is the way it works, we are dependent on this one being right, you're shooting yourself in the foot. And that is what EU is doing, because there are, even in our group, we argue what's the primary current flow. Like, I've always been for flow through the solar system, as opposed to only secondary currents between planets, not the primary current. The primary current is through the solar system, in my opinion.
And I love to debate that.
Right.
Yeah, but that makes it live and makes it a dynamic.
Right, but I'm not in a position to. I would hope I wouldn't, if I was in this position, just say we're not going to hear any other stories other than mine.
Yeah. I mean,
I'm at least not in a position where I could do that. I can't say, well, this is how it works, and everybody else, well, forget you.
And then discount it, just like where the problem is with the mainstream now.
Yeah, exactly.
But it's important to know some of the dynamics, like that. If you're going to argue that, since there's no room for electrostatic attraction between the sun and planets, and you want to argue that they're shielded from each other, then you better not put them in the same. You better be careful putting them connected by this rope and then saying they're shielded from one or the other. Okay, not both. You can't go when it's convenient from one idea to the other, and EU does that.
Well, I would think, and let me just be fair, certain people who are, we're going to call, and I don't want to say it this way, but who have self-deified themselves in that aspect of the EU, might be saying that, but that doesn't necessarily mean that it's true. I mean, I know that Hans Alfvén's first attempts at understanding this were totally wrong. He tried to self-correct, didn't really work out so well, but it still was the basis of all conventional astro, ambiplasma, that kind of idea. But in his correction, he blossomed this plasma cosmology, and that plasma cosmology was seized upon by the Velikovskians. And because they came out at relatively the same time, Velikovsky died in 1977. In 1977, Hans Alfvén is still going strong. David Talbot is reading the stuff. It's about 1990 now. The merger came along where Talbot and Thornhill met. That's where the official bridge between these two groups became the quote-unquote electric universe. Now, that's where it spawned from. So obviously, they pay great homage to Velikovsky and the ideas. So they're linked together, inseparable. But as much as they are the electric universe, at the end of the day, I think that we can recognize that I see that as this is something that is very inspiring stories with Velikovsky and should be given great, great weight, I guess, because I mean there is some evidence there, but on the purely scientific, let's challenge the mainstream. I think we should leave that to plasma cosmology. Let people find the electric universe on their own.
But I mean, but why does it need to be like one angle? It's kind of this is one of the things that I think is important, is that it should be inquiry, and instead of, okay, this is our position, it's like inquiry, and then here are alternative ways of looking at this thing. Why isn't this allowed in the mainstream? If you can support it empirically,
Which part?
Any part. I'm running into one in math that's really significant right now. That's foundational. Real numbers, by the way.
Well, I see the potential of this. I mean, as much as he might be yelling, and I don't mean to say that he's really yelling, but he's complaining about this, and that there should be a distinction. And as much as he's correct, there is. But this is a movement, a group that is not bound by the constraints of conventionality in that sense, and is adopting more and more people into it at all times.
Well, the problem is if you say you're EU, you're associating with some dogmatic positions.
I listened to this Joe Rogan, Joe Rogan talk earlier, and they were bashing the electric universe cosmology to the point where this guy said where he works, and you can come meet me there. He's like, I live in LA.
Yeah, and it's totally superficial. Totally superficial.
Completely bashing it, making fun of the EU to the fucking nth extent with Joe Rogan. Okay, so that's why you don't see that mainstream cosmology on there, because they already chose theirs with Neil deGrasse Tyson and etc. Because that's the platform that he interviews. So.
Well, they were kicking. Anyway, that was an interesting little piece you shared today, buddy. So.
Yeah, I sent it to David a real quick 8 minutes in on this video, which they're completely talking about something totally different seconds before, and then they bash it right into the center of, like, while they're making fun of Christianity and flat earthers at the same time, and
they're putting it in the same box. Yeah.
Yeah,
talking about boxes because they're boxes all over the place. And I think at least I'm personally inspired to break all the boxes. Why is the box there to begin with?
Mm-hmm.
Well, he's trying to make this point, and it won't make any difference. At the end of the day, the only thing that the thing that plasma universe people have, because at the end of the day, the plasma universe people are right.
just to break some more boxes.
They're right that if space is made of plasma, that there's going to be a plasma in the universe,
the tacit use of language bugs the shit out of me.
So this is what I think. I think that the EU it thinks it has a way of becoming a GUT, a grand unified theory, when it's not really a grand unified. It's not a grand unified theory, but that's what people are holding on to inside of it. And we're dealing with things: electric biology, electric math, electric geology, electric art. We're dealing with all sorts
the model
of
electricity itself.
Yeah. But see, inside of it, there's little chapters, there's little books, and it needs to be divided into chapters, like electric universe, plasma physics. Ta-da. And then you have all of this different stuff in the same chapter. Yeah, there's a box, you subdivide it, and But if it thinks that it's a GUT, then it needs to stand out and say that, where we're all just kind of grouping together, and it's very biologic in nature, a grouping of individuals who are looking at new things from different horizons.
Yeah.
Well,
so anyway, sorry to be a little bit aggressive.
No. I've already told everyone this, that the EU is very encompassing compared to plasma cosmology, and there's no doubt in my mind that's the case. I mean, like I said, I would not go up to Neil deGrasse Tyson and go, "Hey, let me tell you all about how cool mythology is, man." and that's not going to fly, right? But to go around and say, "Well, no, let's talk about, the force of electricity, and let me talk to you about plasmoids and what a plasma focus is." Well, this is plasma cosmology. It's much stronger a foundation than the electric universe. To me, the electric universe is like a collection of things that people are seeing the connection with, the possibilities that it might lead to, as you said, a grand unified theory. But it's not that yet. The thing is, though, is that plasma cosmology, more or less, is the story about plasma and the way that it would work under the laws of electromagnetism, or the laws of Maxwell, and how those should be combined with the laws of Newton to make a more homogeneous idea of the way that the universe works. That, I think, is going to happen no matter what. The electric universe is just a subset that will be a door that will be opened as people begin to incorporate this new idea into all of the old sciences. But I don't think it's going to be...
I think what might be wrong here, or could be the problem, is the name. It gives way to allowing one to come up with vortex universe, the toroidal universe, the helical universe, and then all of a sudden you're subdividing all of these when really they all have to do with each other. So if you pick the name electric universe, and then people start saying, well, what about plasma? What about toruses? What about plasmoids? What about vortices? What about, and atoms, the atomic theory, the electric universe atomic theory, with Ito. And, there's a lot, and consciousness. It opens up. Everybody wants to try to name things, but in naming things, sure, there's origins and stuff, but unless you're claiming it's a grand unified theory, people should just back off and relax. We're just observers and scientists and ordinary people experimenting.
Right. There's these false boundaries and borders there that get formed, and it's like, and there's a lot of energy around these borders, and it's like, why? And but this is the nature of how we currently operate in our collective thinking.
Yeah,
also the nature of paradigms.
As human beings, I would say, people like using even such a sort of remote ideas, scientific ideas, as basically political banners, to kind of to attack other people. Oh, you're wrong. My idea is correct, and so on.
Right.
Yeah, and I think it boils down to the simple fact that people like certainty, people like something familiar and comforting because of that.
Yeah,
and if they can use it as a weapon, so to speak, as a weapon in an argument with other people, they would certainly do. But at the same time, I loved your kind of approach where you said that. It's cool to be open-minded and so on. And Jim also emphasized that, and it's all, I agree with it a lot, but I'm not sure whether it is fitting for big groups of people, because I think that big groups of people actually tend to they like to be confident, they like to have certainty. And if it comes to sick individuals like myself, I at least can entertain a level of skepticism that basically I can have two contradicting theories in my head and be interested in both of them at the same time. But I understand that nearly not anyone is so schizophrenic as myself. So people still would like to have something solid and certain. So that's because of that we have these political arguments essentially inside of the
nature
EU,
of things.
even inside of the EU. Not even talking about EU versus mainstream or whatever, EU versus plasma cosmology.
Right.
Right. So my point is that openness is cool, but it doesn't. It's probably not fitting for everyone.
But this is the interesting thing of what we're facing. The ability to do this. What we're doing right now is kind of it's got its own type of Lichtenberg pattern to it, that we're all located in different places and have very kind of similar interests. Although even within the group, there's this dynamic going on. It's pretty interesting. But this is a beautiful thing, and I think there's that where you couldn't do this before. There's a lot of energy in exploring this, and is there a necessity to collect a group of people and then have a unified theory of anything? It's like, why not just be amazed with nature and like, oh, look at this, and doesn't it do? Look how it does this, and is this like this? Just open-ended,
I think what happens here is ego and personality form certain cultures, and individuals collect around these figures that see things in a different view, and then it becomes like its own little organism.
It's a cult of personality often, And
yeah.
And that's kind of, I sense a certain poison to that,
Well, I think it's 100% natural. When you get a figure who has a point, you're going to have people follow that point and then look to the figure for the next move. Like Dale Pond and sympathetic vibratory physics, SVP, and Torus Tech. I'm not sure what they're all doing with Torus Tech.
It's fascinating. The direction they're going. Yeah, but is it? Do you believe he's a like that cult of personality with him?
Well, he incorporates all the stuff that you and I particularly are very interested in.
Absolutely.
And he takes it from a perspective of all of the different types of scientists and free thinkers, radical thinkers, designers like Walter Russell, Keeley, everybody, and he looks at their models and kind of puts it together. And Victor Schauberger, and
right,
it's the same with Jason Verbelli.
Right.
He kind of put it all together with the real verbs, and you have a person there who kind of collects stuff and shares it. Like you, David, you have a collection and you're sharing.
Yeah,
and
it's
like
fun and it's energizing actually. But it's like I'm reticent to go. Oh, I got the answer. Like I got a. This is an interesting parallel that seems to answer things. It's like, let's look at it, and I'm all into kicking it hard, kick it hard, because you want if you want anything to run, you got to put it through the stress test, of course.
Yeah.
Right?
And it's not a bad thing to have a cult of personality, because there's a lot of.
Believe me, I know it flies. So
yeah,
I'm at ground zero here. So.
You know what I think of what's very attractive for the electric universe theory, and in comparison to the plasma cosmology and whatnot.
Women in red dresses.
How did you know?
That's always
Venus.
what I go for.
You're always talking about Venus. For me, it was a platform that provided a scientific avenue to explain the religious and cultural aspects of the society we live in, and for something. It's the first thing I've ever experienced. I've said it before, but it's the first thing I've come across that puts both into one bucket, that creates an avenue for non-judgmental or not. To me, it gets rid of the idea of the racism and cultural divisiveness of gods and beliefs and all of these things worldwide. It's finally a scientific platform that can put together some sort of realistic, understandable answer to all the things that anybody from any culture has ever grown up with, myself including. And that's what brought me into the electric universe.
I have to state that I apologize for not having said that before, because you're absolutely right. That is 100% the thing that it makes that extended family I talked about, the extended part of the EU, different than the plasma cosmology. And it's right there in a nutshell. It's just not necessarily scientific. It just calls to people, many people, and it explains things that normally would remain mysterious, and I don't like that. I don't like that feeling. To me, to know that symbol over a doorway is about this, or know that the G and the little compass thing on the Masons, I know what that means now. I got this symbol over here. Oh, that's a symbol of Venus. So that's a symbol of this. You have an idea, and it's no longer scary. It loses all its magic.
Down
over
to the G,
still scary.
The seventh letter. Seventh letter. The G is a both uppercase and lowercase spiral, and it stands for geometry. The geometer. Woo! Here we go.
Hear him a biff. I hear him a biff.
Come down to geometry because geometry is an exact science and an exact math, and there's no denying.
This is the funny thing
that I'm the only ways to prove something.
The funny thing I'm going to go with, because
I was just going to say, and let me just finish, is that when Dave mentioned that it allows me to have respect for religion as much as you were trained not to. Like you were told one thing, that you weren't supposed to respect this because it's all myth and it's all bullshit and blah, 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 blah. But then you come back to it and go, wait a second. These guys were trying to keep the light alive all the way through here. I mean, they didn't do a perfect job, but they did a good job. We're still talking about it thousands and thousands of years later because they're saying, hey, this shit's important. To me, that's amazing. That gives me a little bit of hope.
Talking about metaphorically too.
That's the thing. Is it metaphor or is it not? And that's the whole EU thing, right? So anyway.
I would agree. And again, the thing that brought me to the EU was symbols of an alien sky. Yeah, and it just I felt so overpowered and literally crazy. I mean, about the symbols, because in my culture, I mean, local symbolism of ours is also. I mean, I've seen those same patterns everywhere around me ever since I watched the symbols. Yeah. So it was kind of, I mean, it was sort of a, I don't know, metaphysical transformation, so to speak, of mine. But reflecting upon it, I mean, years later, right now, I mean, I watched it in 2014, 4 years ago. And thinking about it right now, I can say it was sort of an irrational experience. It was, almost like a religious feeling of connection to the humankind, I guess, or something like that.
Amen, brother.
Yeah. And I cannot say that it is scientific. I mean, this feeling on its own, but yeah, you're absolutely right that it opens avenues that were impossible to imagine before. I mean, yeah, it kind of allows a whole new sets of theories to be constructed just by using this very same, approach that we have here in the EU. And it's great, in my opinion.
Right.
I would like to say a couple things, and I have to go. It's been a really great listen. I've listened quite closely, and I kind of think that symbols are really just symbols, and they can be used by any different side of anything that understands how to use them. Sort of like a magnifying glass. It's made out of glass, but it's the shape of it that actually does the work. If you just make a pane of glass, it doesn't do anything. But you can use a magnifying lens to be able to see better, or you can burn somebody's eyeball out with it. So it depends on how it's being used. And so the symbols actually do work. They have power. The shapes of things. One of the things that I just saw that made me have one of these emotional movements was that yesterday I was watching a video, and it was talking about and it's probably a website I wouldn't watch any of the other things that they have listed, but was talking about these cubes and all the stuff that represents Saturn, and that Saturn represents Lucifer, and that Lucifer is this evil thing of the devil. But in the Latin language, the Lucifer was their name for Venus. So it's just like what you're saying is that they really worshipped Venus in the cosmology that they saw at that time, because that's what they saw. And now it's degenerated into, it means satanic worship of evil acts and everything. But it's the same symbol, so they're used in times. And I also think that intelligence or understanding the truth has been what has been the destruction of all wars from all time. It was the constraint of knowledge. And then the secret societies were trying to save this understanding for when it was going to be used. And it changed into a lot of different things. But it is coming clear, and that's to me what the EU was. I had a rock that I ran around with and talked to all the scientists in the world about it, and they're confused. I had a lot of fun, but it brought me into this rock was different than the others and what caused that. And now the EU has opened up a whole exciting world of everything. People talking about how your aura is and how your feelings are, and electric conductivity, and tuning forks that make you healthy. Of course, that's what the Egyptians used. So the whole thing is an exciting adventure. And to get upset with anybody because of a viewpoint that might seem outside of your ballpark is kind of what keeps the energy flowing. Mm-hmm. So I appreciate being part of this, and I thank you for letting me be here.
Thanks, Robert.
Robert, nice. Beautiful.
Anytime, man. You're always welcome.
Thank you.
Great. Yeah, thank you.
Awesome.
Thank you, Bob.
Illuminati confirmed.
There, yes. He's one of them. Go get him. Yeah.
And that's one of the things that, if you think about it, that they have to challenge the EU, because if you don't make fun of the EU, if you actually start following it, then anybody would recognize that the God you're fighting for over there and the God I'm fighting for over there are literally the same thing. The things we're fighting over are stories that people saw in the sky.